Hi everyone, welcome back to our channel. Today we are going to solve lecture 12 part B, the derivation of power in a pure inductor. The formula for power we are going to have is small instantaneous voltage into small instantaneous current I. So we can be written as V m sine omega t, and I can be written as I maximum sine of omega t minus pi by 2. So now I am multiplying this equation with minus, so or take minus as outside. Therefore, you are going to get minus Vm Im sine omega t and sine of pi by 2 minus omega t. Okay, so here sine 90 minus theta. So we already know that sine 90 minus theta, which is equal to cos omega t. So therefore you are going to get as minus Vm into Im. So this is sine omega t and this is cos omega t. So already we know the formula of sine 2 theta is equal to 2 sine theta cos theta. I require the value of sine theta, cos theta. Therefore, I am going to get sine 2 theta by 2 is equal to sine theta plus cos theta. So here theta is replaced with omega t. So therefore, here you are going to get as minus Vm into Im. So sine and cos theta I can write on it as sine 2 omega t divided by 2. So therefore this value is minus Vm into Im divided by 2 into sine 2 theta. So 2 theta can be written as 2 omega t. So now this power is observed for a full cycle if you take. Okay. So whenever generally we say that this is 2 into 2 pi f. So fundamental frequency is 2 times, automatically this magnitude becomes as 0. Now let's try to do the proof also, nothing to worry. So therefore the average power we are going to get it as integral of 0 to 2 pi. A complete cycle I am going to integrate. So the complete cycle I am taking up to 2 pi. It has a positive cycle and negative cycle, and I am going to calculate the average power. Okay. Therefore, the average power 0 to 2 pi minus Vm Im by 2 into sine 2 omega t. So already we know that integral of sine theta is equal to minus cos theta. Okay. So from here, how I can write down it is this is Vm Im by 2. So integral of sine I can write down it as a minus cos 2 omega t divided by 2. So minus into minus is plus. You are going to get Vm Im divided by 4, 2 into 2 4 into cos of 2 omega t, and the limits are from 0 to 2 pi. Okay, so therefore here we are going to get Vm Im by 4 into, so substitute the limits, we are going to have cos 2 into 2 pi minus cos 2 into 0. Okay, so when you do it, then the equation is simplified. So sine 2 pi, sine 0 is how much? 1. Sine 2 pi is how much? 1. So 1 will get cancelled out. Therefore the average power consumed by an inductor is equal to 0. Okay, so this is what the proof. The average power consumed over positive cycle and negative cycle is 0, but it consumes energy. Okay, so power consumption is energy, but the inductor, as soon as you give the supply, it will try to store the energy. Okay, it stores the energy whenever the source is available. So whenever the source is available or AC or DC supply is available, it will try to store the energy when with the polarities of positive and negative. Whenever the source is not available, it will change its polarity and maintain the magnitude of current, which is nothing but it maintains the current magnitude which will discharge the energy. This is what the behavior of an inductor. Okay, so therefore we are saying that now let us try to draw the power curve. We will try to understand how the average power is 0. Okay, so we have the equation of V of t. When you plot it, this is omega t and this is V. Okay, so we have the sinusoidal waveform of this fashion. Okay, and current. So we have the formula V equal to Vm sine omega t and I is equal to Im sine omega t minus pi by 2. So minus 90. Here minus 90 means here you are going to have 90. Okay, now let's try to change the color and draw it. So here the waveform will have an negative magnitude and it comes to at 90 0 and it again maintains the same magnitude and it comes to 0. So this is the instantaneous current I of t. This is the voltage V of t. Okay, so like this we are going to have the current and voltage. So now let's try to understand it for the all the 90 degrees. Okay, this is for first 90 degrees. This is the next 90 degrees. So this is at 90 degrees what are going to get, and this is at 180 degrees, and this we are going to get it as 270 degrees, and this is 360 degrees. So now let's try to plot the graph in another color. Okay, so here voltage is positive and current is negative. Positive into negative is once again a negative. Okay, so here you are going to get the negative. So here you are going to get negative. Okay, here you can see here voltage is positive and current is also positive. So in this cycle the power you are going to get like this. Okay, and coming to this cycle, here voltage is negative, current is positive. Positive into negative is once again negative. Here again voltage is negative and current is also negative. Negative into negative you are going to get positive. Here you can see here the area occupied in the 180 degrees of negative area and positive area both are same. So here the negative area and positive area both are same, and I can say that a pure inductor which not having any resistance, a pure inductor will have or will not consume power. Okay, it is not consuming power, but this inductor will just store energy. Okay, so what is the energy that is stored by the inductor is half L I square. It stores, so it will store the energy whenever the supply is there, the terminals of positive and negative. Whenever the supply is not there, it will try to change its polarity and the stored energy will be discharged. This is what the behavior of an pure inductor whenever supply AC supply is given to our inductor. Okay, so this is all about how to understand the power consumed by our inductor, and the average power is 0 and energy stored is half L square. This is what the derivation is concerned. If you feel the content is useful, please give a like to the video and share the video with your friends. And if you have any doubts, let me know in comment section. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so kindly support this sort of free channel for the development of students and staff. Yours obediently, Ram.